Hey everyone, and welcome to The Explainer. Today, we're going to do something truly foundational. We're going to explore how a complex geometric reality is built from absolute scratch. We're literally stripping away the messy physical world to construct a universe using pure, rigorous logic, guided by one of the most legendary textbooks ever written, Kiselev's Planimetry. Now, to really grasp the gravity of what we're looking at, we have to recognize the massive historical impact of this single book. As the translator, Valery Monakin, points out, this wasn't just another math textbook. No, this was the absolute gold standard for generations of students. It's a masterclass in mathematical clarity, where scientific rigor meets exceptional teaching. It essentially shaped an entire era of mathematical education simply because of its uncompromising logic.
All right, let's take a quick look at our blueprint for today. We'll be covering 1. The geometries are, 2. Building the geometric universe, 3. The perfect loop, 4. Where lines collide, and finally, 5. Measuring the universe. Let's get right into it.
Starting off with Section 1, the Geometry Czar, how one man's book taught an empire. Let's briefly walk through Kiselev's timeline just to understand this enduring legacy. Born in 1852, Kiselev dedicated his whole life to school-level teaching. When Planimetry hit the shelves in 1892, it spread like wildfire, quickly becoming the standard across the Russian Empire. By 1938, it was revised and adopted as the officially approved geometry textbook of the Soviet school system, and it stayed in continuous use for decades. And now, with the 2026 English edition, we get to experience a book where, honestly, every single sentence earns its place.
Moving right along to Section 2, Building the Geometric Universe, the countdown to nothing.
Okay, so here's where it gets really interesting. We're going to strip reality down to its absolute bare minimum. Imagine taking a physical, 3D object and just peeling away its dimensions one by one. Kiselev starts us with a geometric solid, bounded on all sides by a surface. But through the magic of abstraction, we separate that surface and imagine it has absolutely no thickness. Then, a piece of that surface is separated by a line, which, again, we have to imagine has no thickness and no width. Finally, we drill all the way down to the ultimate minimalist lifestyle choice, the geometric point. It separates a line, but it has no length, no width, and no thickness. It's just a location, and absolutely nothing more.
But you might be wondering, why go to all this trouble? Well, the crucial point is that this total abstraction of points and lines wasn't just some mental gymnastics. It was invented to solve very real ancient problems. The word geometry literally translates from Greek as land measurement, because back in ancient times, its main aim was exactly that, measuring distances and areas on the Earth's surface. We abstract the messy real world into perfect points and lines so we can actually measure it perfectly. So, from that tiny dimensionless point, we start building up. We introduce the straight line. And the fundamental rule here is beautifully unforgiving. Through any 2 points in space, you can draw a straight line, and only one. Because it extends infinitely in both directions, if you lay 2 straight lines on top of each other and just 2 points match, well, the entire infinite lines must match perfectly. They are locked in for good.
Which brings us to Section 3, the perfect loop, circles and superposition.
Now let's take those straight lines and bend them using a compass. If we plant one leg at a center point and trace a continuous line equidistant from that center, boom, we get a circle. Here's the rapid-fire anatomy that gives us the toolkit to understand how loops operate in our geometric universe. The radius joins the center to the circle. A chord joins any 2 points on the circle. If that chord passes right through the center, it's a diameter, which is exactly 2 radii. And any piece of the circle itself, that's an arc.
And what you're seeing here brilliantly illustrates an arc. It's a foundational building block of the circle. By isolating an arc, just like this, we can manipulate it, add it to other arcs, and eventually measure the whole shebang. It's a dedicated segment of the perfect loop.
But how do we actually know if 2 arcs are exactly the same? Well, Kiselev relies on this wonderfully physical concept for proof called superposition. Imagine picking up one arc, almost like a magic trick, and perfectly placing it over another. If you make the starting points match, and the curve follows the same path, and the end points coincide, then all those intermediate points have to coincide too. Why? Because they're all the exact same distance from the center. This physical idea of superimposing shapes is Kiselev's absolute favorite way of proving congruence.
All right, on to Section 4, where lines collide, forming angles.
We've built infinite lines and perfect circles, but now we need to explore the intersections of our universe. What happens when things crash into each other? When 2 half-lines or rays shoot out from the exact same point, they form an angle. The point of collision is the vertex, and the rays are the sides. This simple, elegant definition sets the stage for how these sharp collisions physically divide space itself. Notice how the sides of an angle literally slice the entire plane into two distinct worlds. You have an interior region and an exterior region. The interior is usually the area where a segment joining any 2 points on the sides would be completely contained. It's an absolute boundary, made out of pure logic.
It's super fascinating to compare what happens when we start stacking these angles together. If you add angles until the sides form a perfect extension of one another, you get a straight angle, basically a flat line. But if you keep wrapping that moving side all the way around until it coincides perfectly with where it started, you get a full angle, or a paragon, completely covering the entire plane around the vertex. No way out. And that leads us to our final section, Section 5, Measuring the Universe, the 360 system.
Here is where we introduce a very famous number, 360. Imagine taking a perfect circle and dividing it into 360 equal slices. This ancient foundational number gives us the ultimate unit for dividing a circle into arc degrees and, by drawing lines to the center, into central angles.
And that right there creates the angular degree. It corresponds to exactly 1/360th of a circle. And if you need extreme precision, you can slice it even further into 60 minutes and then into 60 seconds. But the really critical takeaway here, an angle's measure is completely independent of the circle's radius. Whether that circle is the size of a tiny coin or the size of a massive galaxy, an angular degree is purely a universal measure of inclination.
Armed with this universal measuring stick, we can quickly break down the 3 main classifications of angles. These basically act as the structural joints for all geometric shapes. A right angle is exactly 90 degrees, 1/4 of a full angle. If an angle is smaller than that, it's acute. If it's larger than a right angle, but smaller than a straight, flat line, it's obtuse. And the beautiful thing is, all right angles anywhere in the universe are perfectly congruent to one another.
Now, when 2 straight lines intersect each other at perfect 90-degree right angles, we call them mutually perpendicular. Notice how perpendicular lines offer this perfectly balanced intersection. They don't lean in any direction whatsoever. They create an exact, rigid framework, and it's upon this framework that the rest of complex geometry can be securely built. So, think about it. We started with absolutely nothing, just dimensionless points floating in empty space. From there, Kiselev showed us how to logically pull straight lines, perfect circles, and precise angles into existence, creating a complete, measurable universe. The sheer rigor of this system trained generations to think with absolute, uncompromising clarity. Kiselev built an entire universe using only points and lines. Now that you've got the blueprints to understand the geometric fabric of reality, what are you going to build next? Thanks for joining me on this explainer, and keep exploring.